Precise motion control is critical in embedded systems. But what if you can achieve smoother motion, higher accuracy, and quieter operation without redesigning your entire control architecture? Stepper motors are used in everything from medical devices and printers to industrial automation and positioning systems, where accuracy directly impacts performance and efficiency. But as demands for precision and integration increase, traditional stepper drivers and external control schemes are starting to show their limits. In this tech guide, we break down how Analog Devices' TMC5241 Smart Stepper Motor Driver and Controller solves key design challenges, delivering advanced motion control, ultra-smooth operation, and high efficiency. Stay tuned.
Step 1. Integrated Motion Controller and Driver Architecture.
To understand what makes the TMC5241 effective, let's start by looking at its architecture. This device combines a dual-axis motion controller with advanced stepper driver technology, supporting up to 2 stepper motors in a single compact solution. It also supports microstepping up to 256 steps per full step, allowing extremely fine positioning resolution and smooth motion profiles. This level of integration means that motion control logic and motor drive functions are handled within the IC itself. As a result, it reduces the burden on the host processor, while enabling precise positioning with smooth motion control in embedded applications. Next, we'll look at how this architecture translates into real-world motion behavior during operation.
Step 2. Smooth and efficient motion profiles.
Okay, now that we understand the architecture, the next step is exploring how motion is executed in real applications. The TMC5241 includes an internal motion engine that enables advanced positioning profiles, such as linear and ramped motion, without requiring real-time intervention from the host controller. This allows systems to execute complex movements more efficiently and with less processing overhead. That capability is especially valuable in embedded systems where processor resources are limited or shared across multiple tasks. All right, now that we've covered motion control, let's move on to how the device behaves during real motor operation.
Step 3. StealthChop and SpreadCycle operation modes.
After establishing motion control, it's important to look at motor drive quality. The TMC5241 features StealthChop 2 for ultra-quiet operation and SpreadCycle for optimized torque and efficiency. StealthChop 2 minimizes audible noise by smoothing current waveforms, making it ideal for applications like medical equipment or office automation. SpreadCycle, on the other hand, enhances dynamic performance by improving torque at higher speeds. These two modes can be combined to achieve both quiet operation and strong dynamic response depending on system requirements. So, this dual-mode control lets you optimize for either silence, performance, or both, depending on your application. And that is going to be a huge advantage to have for your design. Next, we'll move into how communication and control signals are managed.
Step 4. Communication and system integration.
With motor control behavior established, the next step is integrating the device into a system. The TMC5241 supports SPI and single-wire UART communication, providing flexible interface options for embedded controllers. This allows easy configuration, monitoring, and control of motor parameters without requiring complex external hardware. In addition, the device supports encoder interfaces and multiple reference switch inputs, enabling precise feedback and positioning control in closed-loop systems. These interfaces make integration and precise motion feedback simple and flexible in embedded designs. Next, we'll look at how the device manages efficiency and power optimization.
Step 5. Energy efficiency and intelligent motor control.
After integration, the next step is optimizing energy usage. The TMC5241 includes advanced features like Cool Step, which dynamically adjusts motor current based on load conditions to improve efficiency. It also includes sensorless load detection through StallGuard 2, allowing the system to detect motor load changes without external sensors. These features help reduce power consumption while maintaining performance, making them especially useful in battery-powered or energy-sensitive applications. Overall, these features do an excellent job of improving efficiency while reducing power use without sacrificing performance. Next, we'll explore how diagnostics and system monitoring enhance reliability.
Step 6. Diagnostics, protection, and monitoring features.
Once efficiency is optimized, system reliability becomes the next focus. The TMC5241 includes extensive diagnostics and protection features such as overcurrent protection, thermal monitoring, and supply voltage supervision. It also supports motor phase temperature estimation and chip temperature measurement, providing detailed system insight. These built-in protections help prevent damage under fault conditions while improving long-term reliability. Overall, these protections enhance safety, visibility, and system reliability in demanding applications. Next, we'll examine how the device performs electrically in demanding environments.
Step 7. Electrical performance and operating range.
At this stage, it's important to consider electrical performance. The TMC5241 operates across a wide 4.5 volt to 65 volt supply range and supports up to 2 arms per H-bridge under typical conditions. It also offers low on resistance, helping minimize power dissipation during motor operation. This wide operating range makes it suitable for both low voltage embedded systems and high power industrial applications. This wide operating range makes it suitable for both low voltage embedded systems and higher power industrial applications. The wide operating range enables use across both compact embedded and high power systems. Next, we'll look at real-world use cases where these features come together.
Step 8. Real-world applications.
Finally, let's connect everything to real-world systems. The TMC5241 is widely used in all of these applications, including medical devices, lab automation, industrial printers, POS systems, and precision positioning systems. And if your design is more compact, the TMC5241 is a great fit. The combination of precise motion control, quiet operation, and efficient energy usage enables high-performance systems in compact designs.
Conclusion.
The analog device's TMC5241 combines advanced motion control, integrated stepper driving, and intelligent system features into a single, highly capable solution. With support for 256 microsteps, dual-axis control, StealthChop 2 for quiet operation, and SpreadCycle for dynamic performance, it delivers both precision and flexibility for embedded motion systems. To learn more about the analog device's TMC5241, visit Mouser.com or click the link below. And be sure to check out our other tech guides because smart minds never stop learning.